Today, the focus of my presentation is data interpretation. Dear viewers, please watch the entire video. At the end of the video, there are MCQs based on the presentation. Dear viewers, let us first try to understand what is data and its interpretation. Data interpretation is the process of analyzing and making sense of data to extract meaningful insights, draw conclusions, and inform decision-making. It involves understanding the patterns, trends, relationships, and implications of the data. Here are detailed points with examples of data interpretation. 1. Data understanding. The first step in data interpretation is to thoroughly understand the data, its source, and its context. This includes identifying the variables, units of measurement, and any limitations or biases in the data. Example: in a healthcare study, data on patient outcomes might include variables like age, gender, treatment type, and recovery time. Understanding these variables is essential for meaningful interpretation. 2. Descriptive statistics are used to summarize and describe the main features of the data. This includes measures of central tendency, mean, median, mode, and measures of variability, range, variance, standard deviation. Example: calculating the average, mean, income of a group of employees can provide a descriptive summary of their income levels. 3. Visualization. Data interpretation often involves creating visual representations of data, such as charts and graphs, to highlight patterns and trends. Common types include bar charts, line graphs, histograms, and scatter plots. Example: a line graph can visually show the growth in monthly website traffic over a year, making it easy to identify seasonal trends. 4. Inferential statistics are used to draw conclusions and make predictions based on data. This includes hypothesis testing, regression analysis, and confidence intervals. Example: inferential statistics can help determine if a new drug treatment is significantly more effective than an existing one by conducting hypothesis tests on patient outcomes. 5. Pattern recognition. Data interpretation involves identifying patterns and trends within the data, such as upward or downward trends, cyclical patterns, or outliers. Example: an analyst may notice a consistent increase in sales revenue during the holiday season when reviewing sales data for an online retailer. 6. Correlation and causation. Data interpretation explores relationships between variables, distinguishing between correlation, association, and causation, cause and effect. Example: a study might find a strong correlation between ice cream sales and drowning incidents, but this does not imply causation. Both may be influenced by warmer weather. 7. Contextualization. Data interpretation takes into account the broader context of the data, including external factors and historical trends that may influence the findings. Example: when analyzing economic data, it's essential to consider the impact of events like economic recessions or policy changes on the data. 8. Comparative analysis involves comparing data sets, groups, or time periods to identify differences or similarities. Example: a retailer may compare sales data from two different store locations to determine which one is more profitable and why. 9. Hypothesis testing is a statistical method used to determine whether an observed effect in the data is statistically significant or if it could have occurred by chance. Example: researchers may conduct hypothesis testing to determine if a new teaching method leads to significantly higher student test scores compared to the old method. 10. Decision-making. Ultimately, data interpretation informs decision-making. It provides insights and evidence that can guide actions, policies, and strategies. Example: based on the data interpretation of customer feedback and sales data, a company may decide to improve a product's features to boost customer satisfaction and sales. In summary, data interpretation is a multifaceted process that involves understanding data, summarizing it using descriptive statistics and visualizations, exploring patterns and relationships, and drawing meaningful conclusions. It plays a crucial role in various fields, from science and business to healthcare and social sciences, by helping individuals and organizations make informed decisions based on data-driven insights. Dear viewers, let us solve some important multiple-choice questions from the presentation. Question 1 is, what is the primary purpose of data interpretation? A. Data collection. B. Data preparation. C. Making sense of data. D. Data visualization. Correct answer is C. Making sense of data. Question 2 is, which measure of central tendency represents the most frequently occurring value in a dataset? B. Mean. B. Median. C. Mode. D. Range. Correct answer is C. Mode. Question 3 is, what type of data visualization is commonly used to show the distribution of continuous data? A. Bar chart. B. Line chart. C. Histogram. D. Pie chart. The correct answer is C. Histogram. Question 4 is, which statistical technique is used to determine if an observed effect is statistically significant? A. Descriptive statistics. B. Inferential statistics. C. Data visualization. D. Data cleaning. Correct answer is B. Inferential statistics. Question 5 is, why is contextualization important in data interpretation? A. It adds complexity to the analysis. B. It helps identify outliers. C. It considers external factors and historical trends. D. It improves data collection. The correct answer is C. It considers external factors and historical trends. Thank you. Don't forget to subscribe to my YouTube channel Education and Teacher Education at Shokim Bilal.